Today's lesson is on the percent of error, and percent of error is a ratio that compares the inaccuracy of an estimate or amount of error to the actual amount. We're going to be using this equation right here to find the percent of error. Let's look at example 1 to help us with this equation. For the scale drawing project, Stella recorded the measurement of the dry erase board as 166 inches. The actual length of the dry erase board is 168 inches. Find the percent of error. We first need to figure out the amount of error. So if the dry erase board was really 168 inches, and when Stella measured the dry erase board, she got 166 inches, her amount of error was 2 inches off of the real length of the dry erase board. So amount of error equals percent times whole. And the whole is always the actual amount because that's what really exists. That's the real length of the dry erase board, 168 inches. To get the percent by itself, we're going to divide both sides by 168. So on your calculator, do 2 divided by 168, and you're going to get a really long decimal. That's going to go on forever. That's an irrational number. To change that to a percent, we're going to multiply by 100. So the percent of error would be a 1.2% error. I just rounded to the nearest tenth. This 9 would round the 1 up to a 2. So what that means is Stella had a 1.2% error on the measurement of the dry erase board. Let's try example 2. You guess that there are 300 gumballs in a jar, but there are actually 400 gumballs. Find the percent of error. Well, we first have to figure out our amount of error, and if there were really 400 gumballs in the jar, but we guessed 300 gumballs, our amount of error would be 100 gumballs. Our guess was 100 gumballs off of what really happened. So the amount of error equals percent times whole, and the whole is the actual amount, because that's really the amount of gumballs in the jar. Divide both sides by 400 to get p by itself, and you should get the decimal 0.25. So to change that to a percent, we'll multiply by 100. So that's a 25% error, which means our guess off of what was really in the gumball jar was a 25% error. Let's try one more example together, and then you can try the last one on your own. Maddie wants to practice free throws in his driveway. He estimates the distance from the free throw line to the hoop and marks it with chalk. Maddie's estimate was 13.5 feet. The actual distance is 15 feet. Find the percent of error. So we first have to figure out his amount of error, and if the actual distance from the free throw line to the hoop is 15 feet, and he estimated 13.5 feet, his amount of error would be 1.5 feet. So amount of error equals percent times whole. Whole is the actual amount, which is the 15 feet. Divide both sides by 15, and you'll get 0.1. To change a decimal to a percent, we multiply by 100. So that would be a 10% error, meaning Maddie's estimate versus the actual distance would be a 10% error. All right, go ahead and pause the video and try this last example on your own. All right, for that one, you should have had an 18.1% error. I just rounded my decimal to the nearest tenth. This 7 would round the 0 up to a 1, so that's how I got that 1 in the 10th place value. How did you do? Awesome. Okay, well, that's it for the percent of error video. See you later.